Welcome to Calculus in the PM. I'm your host, Mr. Sindelka. And yesterday we took a look at this. This tangent line idea as Q moves closer to P. You get a more accurate slope for the tangent line, right? As we move it in. However, you can't do slopes of tangent lines if a graph has a corner or a cusp on it, right, at that point. You could do the slope of the tangent line at this point right here, because from the left or the right, if you approach it with sequence, it comes up with the same value. What's that? Well, I drew it loosely. It was sort of, you get the idea. But that way you're going to get inconsistent results. Sometimes, though, in a science class with graph data, I do use those. In physics and chemistry, I used to when we did rates of reaction, and we'd do that. However, we want a more, I guess, exact way, precise way. So you could use a table of values, but that's going to take a long time. But this came up with the slope of the tangent line being -2 when we tried it that. So there must be a better way than doing this. This one will get you the right result, depending on how much accuracy you want. Go to town. And sometimes you have to use charts to do that. And you will be given chart data in AP questions, sometimes where you approximate using charts. So then, without using a chart, how do you do this? This is where we imagine there's this little distance h between the point P on the x-axis, the x-coordinate of the point Q. We'll call that h. And we're going to try to minimize that distance h so that it's 0, so we take the slope. We work this out. We plugged in, well, whatever your value is for the point that you know, -1 in this case, is the x value. We say, well, the Q value, the second value, will be -1 plus h. And we plug that into the function to find the corresponding y value. We work this out. We plug that into our slope formula, did some manipulation, and then we got to a point where, hey, we still can't plug in, you know how we wanted to let h equal 0. Well, this sounds like a limit, we said, so we'll use limit tricks. Seems like sorcery, but it works. As h approaches 0, you don't actually, philosophically, you're not letting h equal 0, but you're going to get to a point where you could substitute that in. Whether you approach from the left or the right, what would you get if that distance h was 0? So we say, well, I look at this, and I could either think of this as distributing the division to everything on the numerator, or factoring it out and canceling. Either way, you get h minus 2. Substitute in your 0, no problem. And you get the same answer that we did on the chart. -2 was the slope of the tangent line at the point x equals 1. Slopes of tangent lines will be important. And it's so important that we're going to have a name for them. It's going to be called the derivative. But right now, we're going to keep it calling the slope of the tangent line. Using this method, find the slope of the tangent line to this function. Now, we're going to work through this one. I know I left you the other day finding, just incidentally, quick review, if I ask for the average rate of change, that's between the endpoints of an interval, right? And your problems gave you intervals like -3 to 5 or something like that. So those are your two x values of the interval. You have to plug them into the function to find the other values. Y minus y over x minus x, you found the slopes. Here, there's no interval. It's at the exact point you want. So find the slope of the tangent line to the function. This is a quadratic. At the point 2 comma f of 2. Now, right off the bat, I see something that I need to do. I want a number for each. I've got 2 for the x value. I don't have the y value worked out. So I think we should figure out what f of 2 is right away. X squared minus 3x is what I'll put in. So, like you said, 2 squared minus 3 times 2, so 4 minus 6, comes out to be -2, right? So 2 comma -2 is what we're talking about there. That's the point if we graph it. Then I've got to dream up a second point, right?
Maybe 2 plus x.
Sorry, 2 plus x? H, yes. That's right. So this second point, I'm going to call it point Q, and it's going to have a coordinate of x, 2 plus h, and then the function with 2 plus h plugged into it. Okay, and it's always, and Emma had asked too, what about minus h? It's the same thing. But the convention is to use plus h, just to keep it looking the same. So, we've got to do a bit of work to figure out what the function is with 2 plus h in it. F of 2 plus h. So this is composition, right? We plug in, instead of x squared, we have 2 plus h squared minus 3 times 2 plus h. You zip that through a little bit here. Let's see what you guys get. I'll pause. Let's work this out. So we get the h squared. You've ordered it in that order. I don't care if you change the order or not. Plus h minus 2 is what I hear. Is that a good one? Apparently so.
H minus minus.
Yeah, okay. And if you have negative 2 plus h squared, because that's more the order that was suggested by the multiplication, that's just fine too. I'm not too hung up on that. So, we got to find the slope, we're saying. And we already know that it's a limiting process, so let's just start with the limit notation right off the bat. So to find the slope of the tangent line, that's what we're trying to do. I'm just going to use m here. We're going to understand it's for the tangent line. We're using this limit where we let that value of h approach. I put x here as I said h, but it's with h approaching 0. Minuscule, right? And we're going to plug it into the slope formula. So the way we have it written here, I'm going to use my q value for the y coordinate, h squared plus h minus 2. I'm going to subtract y minus y, right? So I'm going to use my y coordinate, negative 2. Oliver, 2 plus h. Minus my x value from the point P, which is 2. Yep, tell me about my mistakes.
No. Can you just solve it and then do the limit?
You could. You could. I'm just saying right now we already know it's a limiting process. I'm just going to throw it in there right away. Get used to starting right away with the limit, because you will once we call it a derivative. I'll insist that it does, so it's probably a better habit. Limit of h approaching 0. When I work this out, I just got h squared, I just got h. The 2's cancel out, the negative 2's cancel out, I guess I should say. And the 2's cancel out on the bottom, so I've just got over h. Essentially, with one of these problems, if you get an expression where you don't see the h in the next step coming out of the denominator, you probably did something wrong. This time I'm going to just think of it as distribute the division, dividing by h, right? So it'll turn into h plus 1. The limit of h approaching 0 for h plus 1. I should put a bracket around this. And there we go. It's 1, right? So the slope is 1 at the point P, where x equals 2. That means if I draw that, arithmetic-wise,
h squared plus h divided by h.
yep.
Oh, h by equals h.
I've crammed this in here, so maybe it's hard to see.
You divided the h out.
I did. You could either think of factoring this expression here and get an h plus 1 out of the factoring and canceling, or else just think of distributing the division. Divide everything by an h. Okay? And that's where the h plus 1 comes from. So we got a slope of 1 for the slope of the tangent line. Okay, so far we haven't even worried about what that meant. Now, I kept some space here because I was going to add to this problem now. How about this? So I'm going to put b in here, sort of an add-on. Find the equation of the line of the tangent line. Okay. Find the equation, EQN I'm going to use for equation, of the tangent line. In slope-intercept form. Let's not even worry about slope-intercept form.
We're going to use 2 points.
Yeah, we'll use it. We'll go with in slope-intercept form. Yeah, we'll go with this. That's y equals mx plus b form. So I'm adding on to the problem. This is value added or something like that. What's the best formula to use for a problem like this where you have the slope and you have 1 point? Y minus 1. That's the best formula going. So I'm going to use that. I'm going to just write it down so you know what I'm talking about. Point slope formula. Even if you want it in y equals mx plus b, this is a better formula. You get it. It's usually less work. Okay. So I'm going to substitute in. By the way, my point that I'm using is 2 and negative 2, right? So I'm going to insert it as if y minus, as if I haven't even thought about it. I'm just blindly putting this in. You would probably put that in as y plus 2. And I actually think you should. I'm just going to show for instructive reasons where this came from. My slope in this case was 1. I'm going to insert that there. And I'm color coding just so you know where the parts come from. X minus the original, or the point's x value is 2. And I'll drop the color scheme now. You know how I was hesitant whether I should say in slope-intercept form or not? The reason being is, if you're just asked for, on an AP exam, an equation for the tangent line, you could stop here. This is an equation, right? Something on both sides of an equal sign. So you could stop here, and I would advise you on an AP exam, or if I purposefully just say an equation on an exam, I'll give you full marks right now. Anything else you do is a chance to make mistakes and lose marks. So just leave it. Now, whether you have y plus 2 or y minus negative 2, that's up to you. But you would stop here if I just said an equation. If I change that to an equation y equals some function of x, y equals g of x, or something like that, then that means my next step would just be, now do you guys see the distinction? If I say an equation, it doesn't have to solve for y. If I say an equation y equals function of x, all you have to do to get full marks is y equals, okay, I'll drop the 1, but x minus 2. You could still have the 1 out there, and then just say, well, move that over, right? That would be full marks if I said an equation. But once I said slope-intercept form, what do you have to do? Yeah. If there was a slope in front of here, a non-1 slope, like if there was a 2 in front of here, you would multiply 2 times negative 2, and then group it with the other subtraction, right? But that isn't the case here. Y equals x minus 4. Okay? So careful reading can save you some time, especially if there's fractions and a chance to make arithmetic errors. Actually, there's even chances to make arithmetic errors here. It's most likely going to be a negative sign error with subtract -2 or when you add it to the other side. So if you catch something that does not specifically say slope-intercept form, it just says an equation, stop as quick as you can. Because you know, you're getting used to this for an AP exam, you're going to do it as quick as you can. Okay. And
Is this a different question?
is this a different question? Yes, it is a different question. At what point? Well, the middle. Oh, I see. You used up your space. Oh well. You didn't. EJ did. That's okay.
Just doing the upper question.
Okay, we're wasting time. Anyways, at what point is the slope of the tangent line 0? What you guys need is a formula to give you the slope of the tangent line, though. Do you guys follow what I'm saying there? Because this might take a little bit of time to... Well, the tangent line is a straight horizontal line of 0, right? But looking at this is a scenario, this one here is a scenario where let x equals a. Okay. By the way, what is it called on a quadratic equation? Because we're dealing with a quadratic equation. What do you call that where the slope of the tangent line equals 0? It's the vertex. You could solve this one by using some stuff, you know how to find the vertex, but we're going to use calculus. You could solve this using pre-calc methods, but let's just think this through. We're saying the slope is equal to 0, right? Except that, okay, my 0 turned into a highlight there. Except that we don't know in this case what the point is. So this is what I'm saying here. We're going to call that A. Seems very abstract at first. So we're going the other way around. We know what the slope answer is. We just don't know what the point we started with is. This is an abstract question. We'll try it out though. So we're going to let x equal a instead of the previous question. We let x equal 2. A represents a number like 5 or -3 or whatever. Why the heck? Why the heck would I get a call from Colorado Mills, Texas or something like this? Anyways, I didn't read that carefully. It was somewhere, it's like one of those Google listings things or something. Anyways, back to this. We know the slope formula, but we're going to use it for this. Well, let's just point this out here. Our point will be a comma f of a, like before, right? So our q, we'll use this as a model here. Well, there we said 2 plus h. We're going to say it's that number, a plus h. That's our x-coordinate. And a is an actual number. It's not just some abstract thing. Well, it is abstract. And what's this one called f? Yeah, f of x. So
why would it be 0?
no, we don't know what y is. It's you got to plug in your x value to find the y value. A plus h. Okay. We just plug whatever you have for x in there.
Yeah.
This is, it just seems very abstract because we don't have actual numbers. But it's the same as this. We use the 2 plus h there, a plus h here. Our point P is a comma f of a. I don't know what the heck it is, but we'll find that out. That's the whole point. Now this whole limit idea. Before we would have said m equals the limit of h equals 0. We're going to just know that the m, the slope, is 0. Because the slope of the tangent line is 0. So we're going to start that off this way. Now this is a big jump sort of thing here. What color did I use before? 0. Is that black? Yeah, that's black. So we're going to say instead of m equals, we're going to say 0 equals, because we know the slope value is 0. The limit of it, the limit of h approaching 0, and then y minus y. Oh, I didn't work that out, did I? Well, we'll work this out. f of a plus h is, what was it, x squared minus 3x?
What's the same question?
It is the same function, different question.
Yeah.
So, a plus h all squared minus 3. That's why I keep sliding up to check that, though, yeah. So, this is equal to a squared plus 2 groups of ah plus h squared. That's from the first part. I'll just put that in brackets so you know where it's from. Minus 3a minus 3h. If I collect like terms right here, then we'll know what to put into this function. No other a squareds. 2ah, no other 2ah's. Nothing cancels out, does it?
Nothing.
This is just rotten. I'll just write it down exactly as it is.
A squared plus x squared.
And you're thinking, this is terrible. And it's not fun. I really didn't tidy things up at all, did I? I'll make some space. This is going to be big. So, y2 minus y1. Well, a squared plus 2ah plus h squared minus 3a minus 3h. Good grade. Minus f of a. Now that one I didn't work out, but you can do this one instantaneously.
Minus 3.
Yeah, it's a squared minus 3a. I guess so you know where it comes from, I'll just put this one. Minus. Now make sure you have brackets here. A squared minus 3a. That's just a plugged into the function, right? Oliver, all over, yeah. A plus h minus a.
That'd be h.
And it will be h. If you do it correctly, every time it'll be h on the bottom. It'll always be over h if you've done it correctly. For the slope kind of questions, slopes of tangents. And that's a lot of stuff. This equation here, it actually tidies up kind of nicely. Oh, I was using black and I'm going to cut out the colors. So, a squared minus a squared. That's nice. 2ah, nothing else matches it. I'm going to keep 2ah. Just taking a look through here. Maybe I will keep the color scheme just to show that the 2ah was from the red stuff.
3a was left out.
Is the h squared going to cancel? Nope. 3a, they cancel.
Yeah, to do.
And then the minus 3h stays. Now, I didn't show it as I did this, but the a squared and this a squared cancel. They're subtracted. And the minus 3a and this minus 3a, they subtracted out as well. Because it was minus negative 3a. And the bottom turns into just over h. Okay. When I do this, what can you do with all the h's?
You can take them.
Yeah, you can distribute the division. We'll think of it this way. Okay? I'm going to just cancel it out, cancel out that square, cancel this out. Because they each can be divvied out. I can actually now skip right to evaluating the limit. That means I can toss in the 0 and see what this limit would come out to be. Since I'm going to evaluate the limit right now, I can drop the limit of h approaching 0 notation. Now, it's 2a. There's nothing else I can do with this. And a represents an actual number. plus 0, I'll put that in there, minus 3. So according to this, what is A equal to?
A equal to 3 over 2.
3 halves, yeah.
1/5.
Yeah. 1.5, yeah. But decimals if you start with decimals, fractions if you start with whole numbers, and so on, okay? So keep there's going to be a time and place for decimals. So that's the point. Nope, that's not the point. We now need the y-coordinate, but that part is arithmetic. How would you find the coordinate? When the x value is 3 halves?
A in there.
Sub it in, yeah. So, I'm going to follow an arrow up here because I'm running out of space here. F of A, or F of 3 halves, is 3 halves squared minus, what is it, 3? Yeah, x. This isn't nice, but whatever. It's 9/4 minus 9 halves. Now you could do that one in your head, or if you want to change it. 9 halves is 18/4, but then as soon as you subtract it, you might notice something. Halves and quarters, yeah. It's 9 over 2 again, right?
9 over 2. Negative 9 over
The answer is final answer.
Is it positive or negative?
Negative 2 over 4.
Or quarters, yeah. I was saying, I said it out loud. And anyways, sometimes when I talk to people. Okay, slope of the tangent line is 0 at 3 halves and negative 9/4. That's, in other words, that's the,
That's y.
but on the graph of this parabola, that's the vertex too. It just so happens to be. Like I said, you could solve this one easier for this question using pre-calc methods, right, to find the vertex.
And if x was like 1, you have to add 1.
Hang on, I'll just write this down first before I lose my train of thought. Okay. The tangent at 3 halves, negative 9/4. However, we do this with squares because I can tell you one way you couldn't find values, say with a x cubed or x to the 4 or something like that. I wouldn't be so nasty as to give you something. You imagine if this was x to the 4 and this was a cube or something like this. This would really take forever. So that's why we're doing ones where you could actually do it with quicker methods, but it's to teach you this process with easier functions. Okay? So that's why we're doing it this way.